Alright, in this section we're going to talk about properties of logarithms. The first property is called the product property. So it says if you have a log of base b and inside the argument you have multiplication happening with different terms, you can separate this log into two logs. So it would be log base b of x plus log base b of y. So you can separate multiplication inside one argument through addition. Okay, so let's try number 1 through 3 real quick down below. So for instance, you got 16 times x times y all inside this one log. So remember, the base is 10 if they don't write the subscript. So this can be separated into log 16 plus log x plus log y. Okay, and that's all we can do there. The next one, number 2, we can separate them similar into 3 logs, but they're all going to have base 2 instead. So log base 2 of 16 plus log base 2 of x plus log base 2 of y. Now we try to simplify any logs that have actual numbers if we can. So for instance, log base 2 of 16, that's saying, 2 raised to what power gets you 16? So that answer is 4. So we just changed that log just to be 4. So we always try to simplify if we can. Okay, so this is the final expansion. Final answer. I will point out right here on this log right here where it was just numbers, we couldn't simplify that log because that log is saying 10 raised to what power gets you 16. Well, it's not a pretty number if you put it in the calculator. It'll be about one point something. So we'll leave it as log 16 since it looks better than whatever that decimal is. Okay. On 3, we've got natural log, which is a log, so it still follows the product property. And then inside, we have 3 times a plus b. So we can separate this log into natural log of 3 plus the natural log of a plus b. Okay, and that's it. We can't do anything else with this. Okay, there's no rule that says we can separate the addition of terms inside a log, so we can't do anything with that. So be careful. Don't do too much. Okay, so the next property is called the quotient property. So this says if you have division inside the argument of a log, you can separate it through subtraction. So it would be log base b of x minus log base b of y. So whatever's in the denominator of the argument, so in this case y, it'll have a minus attached to it in front. Okay, so let's try that property. So 4 through 7, so we're going to use the quotient property. So we have log base 7 of z minus log base 7 of 49. Okay, and that second log is saying 7 raised to what power gets you 49. So you can put that in the calculator if you're not comfortable with knowing that exponent, but it is 2 because 7 to the second power gets you 49. All right, number 5 we can separate into log base 7 of a minus log base 7 of 14. And that's all we can do because that second log is saying, 7 raised to what power gets you 14. And again, it's not a pretty number. We know it's about 1 point something, so we'll just leave it in log form. Okay, 6 we can change into log of 100 minus log of x plus y. Okay, and log of 100 is saying 10 raised to what power gets you 100. So that's just 2. So simplified, that is the answer. All right, 7, we can separate this into 2 logs. through subtraction. Okay. And I'm going to revisit this problem here in a second after we learn the last property of logarithms. So we'll leave it like that for right now. Okay, the power property says that if you have a power on the argument, such as like x to the p right here inside the log, you can move that power to be a coefficient of the log. So p times log base p of x is the same thing. Okay, so let's apply this property here on 8. So here we got 8. We got natural log of x to the 5th. So we can move that power on the argument to the front. So 5 natural log of x. And that's all we can do with that. 9, we can do the same thing. So we have 5 natural log of e. Okay, natural log of e is just 1. So we just have 5 times 1, which is 5. All right, and then 10, we can change the radical form to be an exponent. So we know this would be 13 to the 1/4. That's the same thing. And then we can move the 1/4 to the front. Okay. All right, and then back to 7. So with this square root right here, right, we can actually rewrite this to be x plus 16 to the 1/2 in exponential form instead of radical form. Okay, and then what can we do with that exponent of the 1/2? We can move it to the front. So using the power property, we can get the log to be in this form. Okay. Okay, so on the back page, we're going to try to combine all the properties. And so we have division going on number 11, but we also have multiplication of 5 and z going up in the numerator. So this will expand into log base 3 of 5 plus log base 3 of z. Right? So anything in the numerator of the argument is going to get a positive log. And then minus log base 3 of w, since w was in the denominator of the argument. Okay, so we'll leave it like that. 12, we have 4 terms in that fraction. We got a, b, c, d. We can rewrite the square root of a just to be a to the 1/2. Okay, so this would separate into 4 logs. Okay, where a and b are both going to have positive logs because they are coming from terms in the numerator. And then we're going to have minus log base 5 of c to the 7. And then minus log base 5 of d to the 2nd. So remember, anything that comes from the denominator, going to get a minus in front of its log. Anything from the numerator, getting a positive in front of it. Okay, and then the last thing we could do is we could move all of those exponents on their arguments to the front to be coefficients. All right. And then 13, we just have multiplication going on inside the argument. So we can set this, we can separate this log into 3 logs through addition. Right, and they're all going to be natural log. And then the only other thing we could do here is move this 8 exponent to the front. Okay, and then we know natural log of e is 1, so 8 times 1 is just 8. And then what else could we do? We could move that 4 to the front as well to be a coefficient. And that's it. That's all we could do there. 14, we've got 4 different bases. We got b, we got a cubed plus 4, all under a radical. We got 125, and we got c minus 8 to the second power. So we got 4 different logs we can expand this into. I'm going to change this a cubed plus 4 out of radical form into exponential form, so we can change it to be to the 1/2 power instead. Okay, so this is going to separate to log base 5 of b to the 5th plus log base 5 of a cubed plus 4 to the 1/2 minus log base 5 of 125. Since 125 is in the denominator, it gets a minus in front of the log. Same with c minus 8 squared. It'll get a minus in front of the log. Okay, and then what can we do? We can move all these exponents to the front of their logs. And this log right here with just numbers in the base and the argument is saying 5 raised to what power gets you 125. Again, feel free to put it in a calculator if you're not comfortable knowing that exponent, but it is 3. 5 to the 3rd power gets you 125. So we can just change that to be minus 3. And then simplify the rest by moving all the powers to the front. Okay, that's it for that one. Okay, 15, I want to condense these logs, so we're going backwards. And so we want a single logarithm, and we want a coefficient of 1. So instead of having something like this, we would move that coefficient back to be an exponent in this case. Okay, so here we have subtraction occurring. So we know we're going to have 1 log of base 10. Remember, you don't have to write base 10 since it is base 10, and that's the normal form for it. So we got log of 4x minus 3 over x in the same argument. And that's it. That's all we can do with that one. 16, we have subtraction going on between these logs. And we have a couple of coefficients as well that we can move to be exponents on their arguments. So this will all change to be natural log of x to the 5th, right? So x to the 5th is going up top because this is a positive log. And then x plus 2 will go in the denominator because the minus in front of its log. And then to the 1/3 power. And so this is an acceptable answer, or you could put the denominator in radical form and say it's the cube root of x plus 2. So both of those are okay. Okay, 17. So you'll notice both these logs by themselves, you cannot simplify into integers or whole numbers, because 3 raised to what power gets you 36 is not a pretty number. 3 raised to some power gets you 4 is not a pretty number. But let's see what happens when we combine them. So we have subtraction going on between the logs. So we know we're going to have division. Same base of 3. Okay, and then 36 goes in the numerator. 4 goes in the denominator. And we can simplify 36 over 4 in the argument. We know 36 divided by 4 is 9. Right? And then this log base 3 of 9 is saying 3 raised to what power gets you 9? Well, we know that is 2. So this all simplifies to 2. All right, 18. We've got 3 logs, all base 7, so they can be combined. Okay, we see subtraction going on in front of a couple of them, so we know we're going to have a fraction. 1890 argument is positive, right, in front of it. So we know 1890 will go in the numerator. 18 has the log with an 18 in the argument has a minus in front of it. So we know 18 will go in the denominator. Same with that last log. You got a minus in front of it. So we know the argument of 15 will go in the denominator. Okay, so we can simplify the argument right here. So 1890 divided by 18 times 15. This all simplifies to 7 if you put that in a calculator. So this last log is saying log base 7 is 7. So 7 raised to what power gets you 7? If you want to think about it in exponential form, is 1. Okay, so last one, 19. We get natural log, 4 natural logs, so we can combine them. So we see minus in front of a couple of them, so we'll put a fraction here. So the first log is positive, so its argument x goes in the numerator. The next log is also positive, so x squared minus 49 goes in the numerator. The third log has a minus in front of it, so x minus 7 goes in the denominator, and that last log has a minus in front of it, so 3 goes in the denominator. All right, let's see if we can simplify this fraction. So we know x squared minus 49 is the difference of squares, so that factors into x plus 7, x minus 7. All right, so we'll see they have a common factor in the top and bottom. So those divide out to become 1. So our final log is natural log of x times x plus 7, which you can feel free to multiply out if you want to, not necessary. So natural log of x times x plus 7 over 3.